Marking one of NASA's most ambitious missions of the century, the James Webb Space Telescope isn't just designed to peer into the origins of the universe, it also aims to search for signs of life on distant exoplanets. Thanks to major advances in technology, we now have the ability to detect planets beyond our own solar system. And with the James Webb Telescope, we have a powerful new tool to explore one of humanity's biggest questions. Are we alone in the universe? One of the telescope's early mission objectives in the search for alien life is the Alpha Centauri system, our closest stellar neighbor and the source of a mysterious signal. In December 2020, scientists from Australia's Breakthrough Listen project detected a peculiar radio transmission coming from this system. A signal at 982.002 MHz appeared to be aimed directly at Earth. Upon analysis, researchers traced it back to the Alpha Centauri system, more specifically to Proxima b, the nearest Earth-like exoplanet. This raised the exciting possibility that the signal may have originated from there, hinting at something extraordinary. Scientists were thrilled with excitement. Could it be that an intelligent civilization from afar was intentionally sending a radio signal to Earth? Before jumping to conclusions, astronomers needed to rule out more common explanations, such as interference from Earth-based sources or naturally occurring cosmic phenomena. Ground-based radio interference can easily confuse even the most advanced telescopes, and space itself often produces unique, rhythmic signals that mimic artificial origins. Since Proxima b completes an orbit around its star every 11 days, any genuine signal from the planet would be expected to show a change aligned with this motion. The mysterious signal was officially labeled BLC-1 by researchers. But before the confirmation process was complete, the discovery leaked to the media. The Guardian quickly published a breaking story about a possible signal coming from the Alpha Centauri system, sparking a wave of excitement among scientists and space enthusiasts alike. The big question, could BLC-1 be the long-awaited evidence of contact with an alien civilization? Unfortunately, further analysis of the planet's orbital period didn't provide the proof everyone hoped for. In fact, it suggested the source of the signal might not even be located on the surface of Proxima b. The way the signal's frequency drifted didn't quite match what was expected. With no clear source identified, astronomers were left once again with only speculation and theory. Still, some experts argue that the extremely narrow bandwidth of 982.2002 MHz strongly suggests that the signal is unlikely, or even impossible, to have come from a natural source. Some experts argued that this was indeed the case, citing a bright and long-lasting optical flare that occurred in the Proxima system just 10 days before the mysterious signal was detected. This flare was also accompanied by a series of intense radio bursts. These radio bursts are characterized by extremely high and brief frequencies, which differ significantly from the nature of the signal known as BLC-1. Still, many researchers speculated that BLC-1 might be an unknown phenomenon related to these bursts. To this day, the exact origin of the BLC-1 signal remains unclear. Now, astronomers are placing their hopes on the powerful new James Webb Space Telescope, which is set to examine the Alpha Centauri system more closely. Alpha Centauri is a triple-star system located about 4.37 light-years from Earth, making it our nearest stellar neighbor. It consists of the binary stars Alpha Centauri A and B, along with a third component often referred to as Alpha Centauri C, better known as Proxima Centauri. The name Proxima highlights that, although it is part of the same star system, it behaves quite differently and likely has a distinct formation history from Alpha Centauri A and B. While A and B are believed to be around 5 billion years old and share some similarities with our Sun, Alpha Centauri B is notably smaller than its companion, Alpha Centauri A. The third star in the group, Proxima Centauri, is a red dwarf with just 12% of the Sun's mass. Had it been any smaller, it likely wouldn't have ignited as a star at all, it would have become a planet instead. In August 2016, scientists confirmed the existence of several exoplanets within the Proxima Centauri system for the first time. One of these planets stood out to researchers because it lies within the star's habitable zone. This means it receives enough light and warmth to potentially support life, yet not so much that it would be scorched into an uninhabitable world. Despite orbiting much closer to its star than Earth does to the Sun, Proxima b completes a full orbit in just 11 days and is still considered a candidate for habitability. That's because Proxima Centauri emits only about 10% of the Sun's brightness. Calculations suggest that Proxima b is a rocky planet, capable of hosting liquid water. Moreover, it likely has an atmosphere, making it one of the most Earth-like exoplanets discovered so far. Currently, astronomers still face major challenges when it comes to uncovering precise details about exoplanets. These distant worlds are usually only detectable when they transit their host stars, appearing as faint shadows, tiny dots, against the backdrop of massive, glowing stars. So, how will the James Webb Space Telescope change that? Developed through a remarkable collaboration between NASA, the European Space Agency, and the Canadian Space Agency, the James Webb Space Telescope represents a $10 billion scientific endeavor. At the heart of this cutting-edge mission lies a 269-square-foot mirror, made up of 18 hexagonal segments, designed to collect light from the earliest moments of the universe, just a few million years after the Big Bang. While exploring the origins of the cosmos is a key goal, the James Webb Telescope also has another groundbreaking mission, the detection and analysis of exoplanets. Unlike any telescope before it, James Webb can identify incredibly small planets located thousands, or even millions, of kilometers away. But its capabilities extend beyond detection. Equipped with ultrasensitive instruments and advanced color filters, James Webb can not only observe exoplanets but also visualize them in unprecedented detail. For the first time, scientists will be able to study their immediate surroundings through subtle shifts in colored light and incredibly precise measurement techniques. One of its most exciting features is the ability to detect biosignatures, traces of water or organic compounds that may indicate life. It can also search for technosignatures, which are not organic, but rather signals that suggest the presence of advanced technology. For example, if the enigmatic BLC-1 signal had originated from a radio transmitter operated by an alien civilization, it would be classified as a technosignature. In the coming months, James Webb may help us determine whether Proxima b is truly an Earth-like planet, and whether it shows any signs of life. We can investigate specific regions of the universe and make educated guesses about the forces at play and their origins. However, the vastness of the infinite cosmos will likely always remain beyond the full grasp of mathematics and science. But must every corner of this magnificent universe be measured and explained scientifically? Perhaps not. We need to reflect on why we're so driven to uncover this knowledge, why we seek to understand the universe so deeply. It's because, ultimately, we're searching for answers about ourselves. Where did everything come from? Who or what created it? And why does it exist? While natural science attempts to tackle these questions through equations and models, it's starting to reach its limits. Yet, some open-minded scientists see recent discoveries not as barriers, but as opportunities, chances to explore the cosmos in entirely new ways. These insights may lead us to breakthroughs we've never imagined. Still, despite all our advancements and powerful tools like the James Webb Telescope, we must admit, our understanding of the universe remains incredibly limited. The infinite nature of space might even suggest we're part of a time-space loop or a sophisticated holographic projection. If that's true, then perhaps we need to evolve, mentally and consciously, to truly grasp the universe's essence. Could quantum computers help us unlock these cosmic truths? This brings us to a thrilling new chapter in space exploration, one that could spark a true revolution. Soon, quantum computers might become so advanced and intelligent that they offer answers to our deepest questions, no longer requiring decades of searching, just the right questions.